Good morning. This is Mr. Herman. Today we're going to be talking about recursive formulas. Now, last week we looked at explicit formulas. These are two types of sequences: arithmetic sequences and geometric sequences. So our arithmetic sequences, those were the patterns we were adding and subtracting each time, whereas our geometric sequences, we were either multiplying or dividing. Now, a recursive formula isn't another type of sequence, but rather a different way of representing them. Okay, so we're going to have explicit formulas, we're going to have recursive formulas, two different types of formulas that we can use. Okay, so in this first video, we're going to be looking at the two different formulas and what they're going to look like. So first of all, you know what a recursive formula is. A recursive formula is a two-part equation that defines where the sequence starts, and describes the pattern. Okay, this should be following along in your notes that you'll be turning at the end of class today. So it's going to tell us two different things. But rather than in an explicit formula, where we would have something that looks like this, so here's our explicit, you don't need to write this down, just want to jog our memory a little bit. We might have it an equals a1 plus n minus 1 times d. So an explicit formula, it gives us our first term, okay, where the sequence starts, and describes the pattern, d, in one equation. A recursive formula is going to have it in two. Okay, so it's kind of nice because it tells us automatically what parts of our equation are, but it's not necessarily the easiest to use. Okay, so there's some pros and cons to it, to whether or not we prefer explicit versus recursive, which is why we have these two representations. Sometimes one will be more useful than the other. So let's start with arithmetic recursive formulas. Okay, so arithmetic recursive formulas. Actually, it's arithmetic recursive. We've got a1 is our first term. Okay? When we talked about our explicit formulas, we said whatever we have down here as our subscript, that's going to identify our term number. Okay? So that's our term number. Then we're going to have to be careful here. This is where it can get a bit confusing. Notation is key here. A sub n plus 1 equals a n plus or minus d. Okay? So I'm going to start from the back. So this plus or minus d, this is our common difference. Then right here we said this was our first term. A sub n is sometimes hard to conceptualize, but that is our nth term. Okay, so if I want you to find the fifth term, n would be 5. Okay, so this right here, I'm going to draw an arrow. It's our nth term. Our nth term. Now this is where it can get a bit confusing. We had said a sub n is our nth term. Here we have a sub n plus 1. Okay, it's a plus. It's kind of hard to see with the video, but a sub n plus 1. That means that we're going to take the nth term and we're going to go one beyond that. Okay? So rather than just say we want to find the fifth term, we're going to use this fifth term to then find the sixth term. So the n plus 1, so a sub 5 plus 1 is a sub 6. Okay? We're going to look at some examples in a minute or two to help us understand this. Okay? Now we're going to look at another type of arithmetic recursive formula. The a1 is going to stay the same. Okay, that's still our first term. And then we're going to have a n equals a n minus 1 plus or minus d. Okay, once again, this is our common difference, d. A n is our nth term, so we're looking for our fifth term. But in this case, we're using the a n minus 1, so that's a term that comes before this. Okay? So sometimes it can help if we're making a sequence here. So if I have a sequence, it starts 1, the first term, second term. If I have my nth term, here's my n plus 1 term. Here's my n minus 1th term. Okay? This n plus 1th term comes after our nth term. Our n minus 1th term comes before our nth term. Okay? We're going to stop here for arithmetic recursive formulas. The next video is going to be on geometric recursive formulas, which are similar in how they look, but what's going to go into them is a little bit different.